This video is a continuation of the previous one on zero divisors. So we want to consider the integer modulo 10, and we get to see the zero divisors for this particular ring. Consider integers modulo 10. Integers modulo 10. So again, integers modulo 10, we are talking of elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you draw the carry table for the ring integer modulo 10, remember we said the zero divisor is a non-zero, so we are going to ignore the 0. 5, 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 8, and 9. So we can fill in here very fast. So we have 1, 2, 3, 4, 6, 7, 8, 9. 2, 4, 6, 8, 0. 2, 4, 6, 8. Is 3, 6, 9, 2, 15 is 5 modulo 10, 18 is 8 modulo 10, 21 is 1 modulo 10, 4 and 7. For 4 we have 4, 8, 2, 6, 0, 24, 4, 28, 8, that's 2, that's 6, 5, 10, 5, 10, 5, 10, 5, 10. For 6, we have 6, 2, 8, 4, 0, 6, 2, 8, 4. 7, we have 7, 4, 1, 8, 5, 2, 9, 6, 3, 8, we have 8, 6, 4, 2, 0, 8, 6, 4, 2, and finally 9, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that is the carry table under the operation of multiplication. So note that the zero divisors here are 5. Note that 5 and 2 is the same as 0 mod 10. 5 and 2 the same as 0 and 10. 5 and 4 the same as 0 modulo 10. 5 and 6 is the same as 0 mod 10. You can also note that 5 and 8 the same as 0 mod 10. 0 mod 10. We already have this. 5 and 6 the same as 6 and 5. 8 and 5 the same as 5 and 8. 4 and 5 the same as 4. 5 and 4. 5 and 2 the same as 2 and 5. And therefore, the zero divisors are 2, 4, 5, 6, 8. The rest are units. That's 1, 3, 7, and 9. 1, 3, 7, and 9. Note that 1 by 1 is 1. 3 by 7 is also 1. And 9 and 9 is also 1. In other words, we can have 1 by 1 is 1 modulo 10. 3 and 7. 3 and 7 is the same as 1 mod 10. In other words, 7 is the inverse of 3, or 3 is the inverse of 7. 9 by 1 is also 1 modulo 10. The inverse of 9 is itself. The inverse of 9 itself. Now, for example, consider the polynomial. Consider the polynomial x squared plus 7x plus 5. We won't solve it mod 10. X squared plus 7x plus 10 is equals to 0 mod 10. If you factorize the left hand side, you'll get it is x plus 2 by x plus 5 should give us 0 mod 10. 0 mod 10. Note that in this we are saying that 5 by 2 should give us 0 mod 10. So note, if we let x is equals to 1, if we let x is equals to 1, then we shall have 3 times 6. 3 times 6 is not equals to 0. Remember, 3 is a unit. So x cannot be 1. If we let x is 2, then we shall have, this should be 4 times 7. 4 times 7. So 4 times 7 again is not equals to 0 mod 10. Again, x cannot be 2. If we let x is 3, then we shall have 5 times 8. 5 times 8. And we know this one is equals to 0 mod 10. So one of our solutions is that x is 3. If we let x is equals to 4, we shall get 4 plus 2, 6 times 9. Again, 6 by 9 is not 0 mod 0 mod 10. In other words, x cannot be 4. Again, let x is 5. Let x is 5. Then it means that we shall have 7 by 12. And remember, we are dealing with mod 10. So this is the same as 7 times 2. 7 times 2. And you know that 7, 2 gives us 4 mod 0. In other words, it cannot be our solution. We can go on and check for x is 6. X is 6, we shall get 8. 6 plus 2, 8. And 6 plus 5, 11. And 11 is the same as 1 mod 10. So x cannot be a solution. If we go on to x is 7, then we shall have 9 by 12, which is 2. And 9 times 2, again, this one is not equals to 0 mod 10. Then 8, we shall have 8 plus 2 is 10, so we have 0. And 8 times 8 plus 5, 13, we get 0 mod 10. And therefore x is x can be 8. X can be 8. Then finally, let x is 9. If x is 9, we shall have 11, which is the same as 1 times 14, which is the same as 4. So this is the same as 1 times 4. And you can see it's not equals to 0 mod 10. So in this particular polynomial, then x can only be, therefore x is 3 or 8. X is 3 or 8. You can see how interesting it is when you are working with 0 mod 10. If it was not 0 mod 10, simply solve x squared plus 7x plus 10 is equal to 0. Then you realize that x could have been negative 2 or negative 5. But now we are getting a totally different solution. X is 3 or x is 8. We have used the method of exhaustion. We have exhausted by checking all the elements in the ring, but note that it's kind of tedious. It takes time. Thank you.